day, we'll pick up where we left off. So again, pens and pencils should be down. Let's hand those up and over. Have out on your desk, please, the note packet that you got from the other day. Let's save this. I posted the instructions last night through the classroom on how to log in and complete out the Math Excel. Who here was able to go through and finish their registration of it the other day? All right. The instructions again are posted on there along with your class code. I found a way, a font that changed it so the number 0 had the dash through it as opposed to an O. So that's posted there. My goal is for us to get it done by the end of the week. If you're able to, try it in the library. If you're having issues with it, let me know. But by and large, I'm assuming that you all should be able to do that. The other thing that we're going to have you all do now is this. Have your calculators, please, out on your desk. And I just checked with Ms. Bailey. I know some of you have your own version of these calculators. I think she said that if your calculator has the most up-to-date operating system, you can like put the hood that's on this calculator on your Inspire. But at the same time, I was going to say, why? We'll give you all of it. What I need you to do is you're going to have your calculators out and press, make sure that they're on, and hit the home button right now. So we'll start off and have you hit the home button right now. So everybody should be looking at the same black screen. And then what you're going to do is press the number 5 twice, and we're going to have you log into the calculators. Now, where you're going to encounter two things. Before I tell you what your username and password are, the first thing that you need to look at is there should be a login button. If that button is ever grayed out, does anyone have a login button where it's grayed out? Because sporadically that happens. If that does happen, take the calculator and turn it over, and all of you can do that right now. Turn the calculator over. You're going to notice two important things on the back of the calculator. One, it has my last name and a number. That number relates to the slot that it goes in over on the side. So if you have number 1, that means you look for slot number 1 and put it in slot 1. The other thing is, underneath in like the middle of it, there's a little button right above the screw that's a hard reset button. If the calculator is ever grayed out, if it's acting funny, if something's not working, if you're not able to log in, just go through and take the tip of your pencil and press that. You don't need to do it now, but press that. It does a hard reset of it. It's sort of like turning off the computer and then turning it back on. It will then connect to it if that login screen is grayed out. Now, in terms of you all logging in, what you're going to do, and you'll see sometimes I'll tell you to log in, and I'm a little bit slow on the uptake, and I will have not started class yet. Your username is going to be the first letter of your first name followed by your last name. So if your name is Mike Smith, you would type in M. Smith. And the capitals don't matter. And your password is very difficult. You're probably going to want to write it down. It's 1, 2, 3, 4. So you might want to write that down right next to your Math Excel password. So your login name. Now, once you've gone through and logged in, your name is going to change from gray to black. So you can see, and if there's any issues, let me know. There's sometimes it always comes up. Now, if your login isn't working, let me know, because I might have done something wrong in the Excel spreadsheet when I was changing it. There's always the one that is difficult. Some people have like an apostrophe. I don't know if anybody in here has an apostrophe in their name. There's obviously not an apostrophe on the calculator, so I don't know how you input that, and I have to go through and manually change it. If you have a hyphenated name, you may have to change it. So what we're going to have everybody do is make sure that you've gone through and logged in. Shouldn't be an issue for us. The thing that's nice is once you all have logged in, what I can do is and what happens when we have class is instead of me, yes. Okay, because I pulled it from a while ago. Just see me at the end before you leave today, and I'll manually add it. Okay. What ends up happening is this. So this right now is somebody's calculator locked, and we switch it up. Whose calculator it is? I can assure you, if I see you drifting off, magically your calculator probably the one that we choose. So if we go in right now, one thing. This is to get you ready for calculus. A lot of you, when you do your computations, do it in Scratchpad. I don't care which one you do it in now, but understand that when you get to calculus, because AB and BC Calc are very reliant on the calculator, you need to determine values and store them in places. You should be getting in the habit of doing your computations in the documents thing. You never need to save documents. I am not very good, by the way, with these calculators. I know Miss Bailey is profoundly good at it. I don't know how much Welker does with them in terms of saving documents, because it has Geometry Sketchpad on it, and he loves that. So if you go in, though, my personal advice is, the quicker that you get used to doing your computations in the document setting, the easier it's going to be for you, because again, you need to save and store number values, and you can't do that from the Scratchpad. It's not going to impact you this year, but going forward, it will. So I don't care where you do them. If you need your calculator to help you out with some of the algebra today, you're more than welcome to use it. But at the same time, understand that when we have tests, there are some pages, some tests that are entirely calculator free, even though the reads will give you them. And there are some tests, I think most of our tests have a calculator free and a calculator section. That's another thing. Again, and I don't want to overgeneralize, because in all honesty, I don't know you all that well. But the one thing that you have to understand, in the past, you enriched children, you will take, if I say 55 minutes, you will literally take the full 55 minutes, and some of you hold on to the test like it's a mother holding a newborn baby. Like, you will not want to let that go at all, ever. If there's a calculator free and a calculator portion of the test, that means you have to have some time management. You know, if there's two questions that are that you're allowed, or let's say, two questions that are calculator free, you're not going to want to spend 35 minutes on those two questions and then say, well, I didn't have enough time to finish the test. Obviously you didn't, because you wasted all of that time on two questions. And I'll give you, I'll try to tell you what the allocation is and say, there's two questions that are calc free, they maybe should take you 10 or 15 minutes, and there's 21 questions that the calculator is allowed on, so you can sort of pace yourself accordingly. We left off last time we had class. We got done with example 2, is that right? Yes? Okay. Take a look, please. We're going to start off at example 3. We've done GCFs so far, and today we're going to extend that out. And I'm not sure how much they've done with factoring with you before, but we're going to give you a good foundation to go off of. Looking at what's there in A, understand that this expression here is a binomial with binomial components. So the expression as a whole is a binomial with binomial components. Looking at this, there is a common factor. Hands up, please, if you can tell me what's common or what can be divided out from the left and the right half of the binomial in A. We'll wait for 6 of you. We've got 3 so far. 4? What do you want to say, please? More than that, because we can't just take parts of binomials out. No?
X minus 5.
The quantity x minus 5 is our GCF. So what's going to happen? That's fine. And again, you're going to go through. I was looking at one the other day, and trust me, like I said before, I'm a pusher. I will, no matter how good you think you are, I'll always find something. The other day, and maybe this was a little bit of a sign from above. This, easy, easy. I believe this will even be a bonus question on the test. Does anyone know what the name of the line between those two is called? You know?
I'm guessing division.
No? Well, that's what it means. That line actually has a specific name. No? The divisor is what you're dividing in. The dividend is the answer from division. This line has a specific name.
Quotient, that's the-
No, the quotient is the answer from division as well. The dividend and quotient mean the same thing.
Oh.
It's called the vinculum. You may want to get that down. What a great, and you know why I know that? And it was funny. I asked the entire math department yesterday. There was one person who's had Miss Miller before.
Oh,
Okay.
See?
See, and I can't, by the way, I can't more strongly encourage you, and she's going to talk. There are 2 or 3 things that I will actively encourage you all to do, because I hate to break it to you, but math opens a heck of a lot more doors in life than some other subjects. I'm very proud of this one. Understand this. I would hope that some of you at least take a comp sci course before you leave. It's very, let's say it this way, you need to try it to see whether or not you'd actually be able to enjoy it. I can't remember, I think he's 24, but if you're looking to see, who makes a lot of money very quickly, it's people who come up with really stupid programs, like the guy who invented YouTube. It was literally not in existence in like 2005. And in 2007, he sold it for about $3 or $4 billion with a B, and there were 7 people on his payroll when he sold it. 7, including himself. So he made a pretty good chunk of change. The guy who created Snapchat, which wasn't around in like 2012, he sold it for $1.4 billion with a B. It was an app that just became very popular, and people started using it. Same thing with Facebook and the other thing. But in any case, he sold that for $1.4 billion, and he's the world's youngest billionaire. He's 24 years old. When he invented it, he was 19. So he's not that much farther away from you. You could come, maybe you have an idea for a stupid app that doesn't even exist yet. Take a computer science course. You may leave here as a billionaire, okay? There's that, and I encourage you to take as many take AP Calc, obviously, and AP Stats as well. But that's the harder part. Oh, the other thing, do math. If you're looking to find something, Math League, as far as I know, doesn't have cuts. I think that they give you a lot of food. There's somewhat challenging math questions, a little bit of a push. The big thing is, it's a resume builder. If you're looking to say, again, you all, by and large, you all are probably applying to some pretty high-level colleges. That one line on your resume separates you from other kids, period. And again, I don't think Math League has cuts, which is why I would strongly encourage you to go through it. And I think it's like once a month. It's not even like they have to practice. Who's done Math League? Do any of you do it? Wonderful. All right, so, in any case, you want to get, what a great bonus question. And it's a sample. Now, looking at this, we identified what our greatest common factor was, which was an x minus 5. I'm going to factor that out from the left and the right half of the binomial. So now I'm going to put a set of brackets, which are just secondary parentheses. What is left on the left when I divide out an x minus 5, or undistribute out the x minus 5? Hands up, please, if you can tell me what you'd be left with on the left. Go ahead. You're left with an x plus 6, the quantity of x plus 6, and then I keep the same sign that was there, so plus. And then hands up, please, if you can tell me what I'd be left with on the right when I factor that out. We'll wait for 6. Go ahead.
2x plus 5.
Terrific. Now I'm not done yet. This is the part where, again, you're going to say, oh, he's a pusher. You're not done. You can keep going. Hands up, please, when you can tell me what you can do once you get to this step. There's almost always more we can do. We've got one person who sees it. Look at what's there. Look at what's there. Go ahead.
Another x.
No, because we undivided this out. So as of right now, oh, you're saying this x? You're talking about taking parts of binomials out, and you can't split up the binomials. But looking at what's there, nothing needs to get distributed to them anymore once they're in that quantity. Go ahead. Okay, what would you have when you did that?
2x squared plus 30.
No? Look at what's there. Yeah. Just add them together. So what would you have when you added them together? That's how you get to your final. All we did is look at the operations that are there. These parentheses that are here can now be dropped. They can be dropped because you're just distributing out a 1 at most, and then the operation that it's indicating to do between them is to add. Is that difficult? Sure. Of course. But you can do that. And this is definitely an extending question. Take a look at the next one. Hands up, please, if you can identify what the LCD is in choice B. We'll wait for 6 of you. What can you factor out from the left and the right half in B? We've got 1, 2 of you, 3. We're going to factor out the quantity m plus n squared. What's left after you factor that out? Now the next question is there more else that you can do to extend that further? And the answer would be no. There's no more condensing that we can do. Go through right now. We'll give you about a 30-second head start. Look at question C and see what the GCF is or what the common factor is in C, and then we'll look for some volunteers. We'll give you about a 30-second head start. Take the question as far as you can. Take a look at what's there. Again, these are obviously very, very difficult. What's common to the left and the right side? How much can you equally divide out from both halves of that large binomial? Hands up, please, when you think you've identified what the LCD is or what you can factor out from both halves of that binomial. We've got 3, 4 of you. Go ahead, what do you want to say?
R plus 2s.
Quantity r plus 2s being squared. Now, what remains from the left half of the binomial when you take out your GCF? What are you left with? Just a p. And then what sign would you be left with in the middle? Now, what would you be left with on the right if you were to factor that out?
Q times the quantity R plus 2s.
So now on to here. Can we extend this further? Is there more else that you can do? I'd argue yes. Who sees? Hands up, please, if you can tell me something that you can do. We're going to see whether or not that leads to anything, but what can you do once you're to this point? You want to say?
Distribute Q to R and 2s.
I'm going to argue that, as you said it, is very, very close, but incorrect. He said distribute the Q out to the R and the 2s. It's very, very close, but one thing is missing. It's a negative Q. Don't forget. And I'm telling you now, I've had, that I can think off of the top of my head, at least 8 99s on the Algebra 2 exam because of a negative sign error over 10 years. It's very, very frustrating. Could you stop here if you wanted to? Sure. Understand that on a multiple choice or something like that, that may be either one of those could be a choice. But I would expect you to take it out as far as you can to distribute out that negative. Now, hopefully that's going to make doing question D a lot easier, because I think that question D, even though it has a lot of steps, is going to be easier than than question C was. Go through, please, right now and give question D a try. You can work forward, work forward. Do as much as you can. Yeah, my apologies for that mistake. Take a look at D. Walk us through how you would factor this. Who can tell me just what our first step is? Hands up, please, if you can tell me what your very first step is. If you saw D and it said to factor that down, we have one person will wait for 8. What's the first step that you did? We have 2, 3, 4, 5, 6. What did I say? Okay, so right away we've identified that binomial of p minus 5 is common, so I'm going to factor it out. Can you tell me what you're left with after you correctly factored out the p minus 5? Okay. The quantity 3p plus 4. All right, so now we're good. Who can tell me what the next thing I'm going to do is? Hands up, please. So wait for 6. What do you want to say?
Distribute the negative and combine the p.
Before you do that, I'm not going to do 2 at once. When you distribute out the negative, tell me what you'd write out.
Negative. So it'd be the quantity p minus 5, and bracket p plus 2 minus 3p minus.
He correctly distributed out the negative, and then the next thing you said to do was what?
Add them together.
Yeah, combine your like terms together. I've got p's and numbers that can go together. Then something interesting happens, and please understand this. Brackets are nothing more than secondary parentheses, and the reason that I can drop these parentheses here is that they have a 1 and a negative 1 as their coefficient. So I'm going to go through and I'm going to combine my like terms. I've got negative 2p minus 2, but then wait a minute. I'm not done just yet. You can tell me why I'm not done just yet. Go ahead.
You can multiply them for 2.
Now, you're going to get, who's taking, well, oh, actually you won't just yet. This is what I call, you're going to arrive at what's called a Boolean loop, which means you're factoring and then expanding and then factoring and expanding. So, most of the time I would say, if I saw 2 binomials next to each other like that, I would say FOIL them out, multiply them together. We're looking to factor this down, which is breaking it down into its smallest components. This is not an acceptable final answer. And it's that second factor. And by the way, at this point, I could have dropped the brackets and only put parentheses, just so you're aware. I see more, though, that can be done on this. Hands up, please, if you can tell me. What do you think is going to be?
You can factor out a negative 2.
Terrific. Factor out not only a 2, but a negative 2, which is great. And what are you left with when you factor out the negative 2? What would be left? No? I still have the p minus 5 on the outside, and I take out a negative 2. P minus plus 1. Okay? And the only thing left is a little bit of a formatting thing. What operation is getting done between this first quantity here and this secondary quantity? There's an implied operation of multiplication. What operation is getting done between the negative 2 and this quantity? That's just implied multiplication. At this point, brackets are just secondary parentheses. I'm going to factor out that negative 2 and put it in front. Was it difficult? Sure. But none of it's new math. There's only so many ways we can ask you to add, subtract, multiply, and divide. Okay? Now, take a look at example 4. And do we have questions on this one? Take a look, please, at example 4. We're going to be asked to factor this out. You've got to decide what your GCF is going to be. Neither answer is wrong, but one answer is more right than the other. Who can tell me what one possible GCF is for example 4? Because there's two choices. What's one possible GCF? Go ahead. An A. There's also a second option. What's the second option? Negative A. Which one would I prefer you to take out? The negative. I can't stand when you leave negatives in questions because this, to me, the one on the left, isn't in a really easy form. The quicker you can deal with the negative, the better everything's going to be. Your brain works better in an adding mode as opposed to a subtraction mode. And the negative is sort of emotional baggage that the question carries along. So the quicker that you can factor it out, the easier it's going to be. Both of these are correct in terms of which one is factored. I prefer you, obviously, to be giving the one that's on the right with the negative A factored out. Questions on that? Let's bounce over. Now, this next set is going to be a little bit, they call it factoring by grouping. And I think that sometimes when this is first presented to you all, it's done in a way that doesn't serve you well going forward. I'm going to ask you to view this polynomial, because it's got 4 terms, view it in terms of 2 separate components. Look at what's in the yellow, the first 2 terms. What type of factorization can you do on the 2 terms that are in yellow? Hands up, please, if you can identify what type of factorization we can do on those first 2 yellow terms. Go ahead. Perfect. You can take out an A. And what's left when you take that A out or take out a GCF of A? So I looked at the first 2. You said take out an A and left with X minus Y. Now I'm going to go over to the green, the next 2 terms. Yeah. You can factor out a B, and you would be left with X minus Y. So you did a GCF once. Now I'm going to look at it and say I'm still looking at that as a binomial expression now with binomial components. Looking at what we have here, I'm not done yet. I haven't fully factored it down. What type of factorization can we do once we're to this step? Got a GCF? Yeah. Of X minus Y. So what are you left with after you factor out? You're left with the quantity A plus B left over after you take out a GCF of X minus Y. Because all I do is I divide this out, put it in front, that leaves me with an A here plus the B. All you did was take out a GCF twice. That's what factoring by grouping is. Go through right now, please, and do example 6 on your own. Factor by grouping, the triggers for it are that there's 4 terms. There's a GCF for the first 2 and a GCF for the second. By the way, is it possible for me to rearrange these and get the same answer? Absolutely. Because what's getting done between those terms? As long as I keep the signs the same, I can move them any place I want to. Let's see how well we do. Document tools, expression. Okay, so go through right now, please. That should go out to your phone. Type the expression in. Now, I think you need to, I don't think this does well if you don't have the parentheses. Those of you that aren't logged in, I don't think it's going to bounce it out to you. Did it not come up? Oh, it's there. If you X out of it, it's under C for quick poll at the beginning. We'll get used to these as they go along, and I'll get used to them. I'm sorry if it boxes you out. But I think once it goes away. And by the way, once you're done, if you go to the drop down here, one of the choices will be submit, and just click that once you're done with your answer. We've got 3 of you so far typing your answer. Let's see what we get. We've got 10 of you so far, 11. Now, let's take a look at what the answer choice is. Let's actually do this. While you're going through and inputting yours, I'm going to go over on the side here. You've got 2 terms on the left. I see that there's a GCF of these 2 and then these 2. So the first 2 I obviously can factor out a 3. From the next 2, my GCF that I'm going to pull out is not an A. It's a negative A. So I'm going to take out the negative A, and then if I take that negative A out, I can do a secondary factorization, because you have a common factor of x minus y. So when I put this together, I have an x minus y and a 3 minus a. Let's see how many of us got to that. It's x minus y and 3 minus a. So let's see. All right, not bad. This one had like a negative sign error. Yeah, it looks like it's factoring out that negative a and recognizing. See, if you take that negative out, something like these answers here, there's just sign errors in there. And at this level, we need to make sure that we're extra cautious about making those. Take a look, please. So that handles that one. Take a look right now at the next one. What can we factor out? In question, look at the first 2 and the second 2. Hands up, please, if you can tell me, what can I factor out from the first 2 terms? We'll wait for 6 of you. What's our GCF? There's 4 terms there. What can I factor out from the first 2 and the second 2? So I go through and factor out a 6 and an x. And what's left, by the way, sorry? Now let's look at the second group. And before I give up, who can see sort of, this is sort of an awkward thing to say, because especially in the first example we said it maybe doesn't count. What can we factor out from the next 2? You want to say? 1. Just a 1. Is it a positive 1 or negative 1? The benefit of factoring out a positive 1 there is now I'm left with the option to factor it again. What's the GCF the second time around? An a plus 2b. And when I do that, I would be left with a 6x plus 1. Questions on that? Let's take a look at example 8. Obviously, it sort of gives it away in the heading there. But sometimes we need to rearrange the terms so there's something in common for us to take off, because I can put these in any order I want as long as I preserve the positive or negative sign that's in front of them. So as I look at this, I guess there's more than one way that we can do this. I look at this and I say I've got a p squared, q squared, and then I've got a 10, and then I've got negative 2q squared and 5p squared. I can either put the third term or the fourth term in this second spot, and that would allow me to take out a GCF. Now, when I went through and redid this, I changed the position and put it so. The second term went here, and then I bounced this last one over to the end. If I arrange it in that way, I can take out a GCF twice. Look at those first 2 terms. Hands up, please, if you can tell me what the GCF is for the first 2 terms. We'll wait for 6 of you. We've got 1, we got 2, 3, you want to say?
Q squared.
And what's left, please, when you take out the q squared?
Q squared minus 2.
Let's look now at the second grouping. Hands up, please, when you can tell me what the GCF is for the second group. Maybe this is easier.
5.
So what's left when you take out a 5? And all of a sudden, our arrangement is nice and easy to factor. You've got secondary, or second set of GCFs. So I'm going to take out that quantity of p squared minus 2, and I'm left with the quantity of q squared plus 5. Questions on that? Now, this is all we're going to go through and do for GCFs. If you want, when I was talking before about some extra practice problems, if you want to do more, you can. And if you need to practice, take it. The assessment that's waiting for you when you come back is going to have GCFs on it. The other thing that I wanted to cover with us, and maybe we'll save this next topic. Well, actually, we should be able to do. All right, let's table this one. Let's bounce over, please. If you can go over to page 6. Or sorry, yeah, it's a page, yeah. Where it's, those examples are, I think, are at the top, page 6. Now, raise your hand, please, if you've done difference of perfect squares factoring before. If you remember that, because I don't remember I don't know what your teacher was talking before. It's been a while. Did you do it in freshman or in Algebra 1 or whatever it is? Okay. All right. So we'll give you a refresher. My hope and prayer is that you already know what your perfect square numbers are. You can give me an example of a perfect square number.
225.
144, 64, 4. Now, 1 is a perfect square, which there's always this debate because 1, it's such an awkward number. Because you can say, well, it's a perfect square, it's a perfect everything. You can take the square root of it. And it means so much. It's a GCF sometimes, but then other times, like example, I think it was 1C that we did when I said factor out a GCF. I literally wrote down, there's a GCF of 1, so it doesn't count. And then when we do ours today, I said, well, what's the GCF we can take out on one of the questions? And it was a 1, and it did count. So 1 is a very awkward number, but 1's a perfect square. When you break down a difference of perfect squares, and notice it's difference of perfect squares, that means you're subtracting 2 perfect squares. The left half of this and the right half of this are perfect squares, and there's subtraction between them. The factorization pattern is you would get 2 binomials that technically are called conjugates of each other. Have you heard conjugates before? Okay, you're going to hear this here. Conjugates mean that you're talking about binomial expressions where the only thing that differs is the sign in between the 2 terms. So you're going to give me out the square root of the left plus and minus the square root of the right. So this would factor down to be the quantity t plus 6 times the quantity t minus 6. For some reason, I don't get why you always put the minus first and then the plus, but if you could look at the plus first, it makes me a little bit happier. You're factoring that down. It's quantity t minus 6 times the quantity t plus 6. I know the order doesn't matter. Take a look, please, at example B. Some of you, I liken it to this. Like, imagine if I were to put a big piece of, let's say, a big piece of chocolate cake at the end of the hallway, and then I stack all of you at the other end. Okay? As a teacher, this is what it's like. There's a big piece of chocolate cake at the hallway, and at the other end of it, there is all of you waiting. And the first person that gets there gets that piece of chocolate cake. And everybody starts running towards it at the same time. Just like you're going to do in this question. You're all going to start running at it. But unbeknownst to you, right here, I put a fishing line going across the hall. Okay? And literally, all of you, as you're running, are you going to see it? What are you looking at? Okay, you walk in, you think you see something, and you run to it. And what's going to happen when you hit right about here? You're going to trip. And we hope you have good dental, because you're probably going to break some teeth. You're going to fall flat. I mean, boom! right on the ground. And almost all of you are going to do that on this question. Because you're going to see this, and the first thing that you're going to say is, oh, it's a difference of perfect squares. It's even what the header said, because I know 4a squared is a perfect square and 64 is a perfect square. And that's so wrong. Who can tell me why that would be wrong? This is not to start a difference of perfect squares question. We've got 3 people who can see why. That's it. I'm hoping for more. Take a look at what's there. What do you want to say in the back? Take out a GCF of 4. The GCF supersedes everything. The GCF supersedes everything. You're still going to be left with a binomial that you can factor down more. But always, to start, look for the GCF. So we get to here. The next thing that we would go through and do is we're going to factor this down. Hands up, please, when you can tell me what your final answer is going to be. In the back, what do you say?
4.
That's 4 is not 16. There you go. There you go. 4 times the quantity A plus 4 times the quantity A minus 4. Hands up, please, when you can tell me what C is going to factor down to. We'll wait for 6 of you. Take a look at what's there. What do we think C would factor down to be? We got no takers at all? Oh, my. Really? We got 1? I'm hoping it's not. I'll give you a hint. There's no GCF. That's what you're trying about. We only have 1, 2. Take the rest. What do you think? Follow the pattern. Only 2 of us? Really? 3?
The quantity 16n plus 29p times the quantity 16n minus 29p.
Your hang-up is you didn't take the square root of the numbers. What's the square root of 16? 4. So what would you say? Revise it. What would your final be? And?
4n plus 9p.
Square root of the left. The pattern is there. Square root of the left plus and minus the square root of the right. By the way, these binomials are conjugates of each other. If you were to multiply them together, your outside-inside terms would cancel out or reduce out. One thing, by the way, that we were going to say, a lot of us need to get in the habit of saying, things don't cancel, they reduce. I'd like to think, if something cancels, it goes to 0, or sorry, sort of evaporates. When we're doing division, things don't cancel, they reduce down to 1. Okay, so let's make sure. The other thing is, I don't know, you guys might be the first group. If you were to ask to multiply these 2 binomials together, do you know what, when I say FOIL, these binomials, you still know what that means, or do they show you some stupid box? What's that? Okay, they show you both. I can assure you, when you go on, the box works, don't get me wrong. And there's nothing wrong with it. You have to do what works for you 1,000 times over. I don't do the box ever. So if you see me go through and you'd be like, well, I do a box, and I give you a little, don't take it personally. Now, I'm going to take a look at D. This again, question D is probably the toughest one out of all of them. I look at this and I say, all right, I've got 81k squared minus the quantity A plus 2 squared. Is the left half of it, this binomial, a perfect square? Yeah. What's the square root of the left going to be? 9k. Then I've got minus, is the right a perfect square? Yeah, what's the square root of the right? And A plus 2. So remember, your factor pattern is, it's the square root of the left plus and minus the square root of the right. So I'm going to start this off and say, all right, the square root of the left, which is 9k, plus the square root of the right, which is A plus 2. Now this again is going to be that trip line that all of you are going to fall flat on your face about. On the right half of it, we've got to do the second binomial factor, so it's still going to be the left plus the right times the left minus the right. So I've got the left minus the quantity A plus 2. Can you simplify that out? Sure. What can you do to take this forward? It's in that second factor. What can we do in this? Rhymes with distribute. There you go. Can you get there? Sure. Go.
Why is it that the second one has parentheses around A plus 2, the other one? Oh, because it's mine. Okay.
Because it's minus the quantity.
Yeah,
If you've got the plus in front, if you have a plus 1 in front, understand, a lot of times we'll just drop the parentheses if you have the 1 in front. Take a look at the next one. This one again, I'd say, I don't want to say is super challenging. I would expect you all at this level to get this right. I want you to give it a try right now. Go through, take that out as far as you can. Try to break that down as much as you can. Follow the factor pattern, the square root of the left plus and minus, the square root of the right, and go as far as you can. Now, looking at what's here, the square root of the left is going to be x squared, the square root of the right is 9. So to start this off, I'd say, well, you're left with a second GCF, so your final answer is going to become, or sorry, not a GCF, excuse me, difference of perfect square. So the right you can't break down. We'll see, actually, technically, I guess you could if you're operating the imaginary number system. We'll do that later in the year. But that's what your answer should be. Okay? Now, the next time that you come in, there's going to be some questions on, your assessment's going to be on factoring. There's questions on GCFs. The one thing that I need you all to do before you go is this. Yeah, there's just factor by grouping double GCFs. What I need everybody to do, so prep yourself for it. I'm not. You do as much as you need to get yourself ready. But if you can do the questions, make sure that you can tomorrow. What I'm going to ask you all to do is this before you leave today. I am going to ask, and we'll have the first 2 rows. Just slide over here, please. I need you to come up and say what your name is to me, because we go through and we have cards to call on you. And what I need to make sure is, like, if your name is like, let's say, Gregory, and you go by Greg, tell me. The other thing is, if I have your name wrong, you need to tell me. And the last thing is, if you're not on one of our things, you need to tell me, because I pulled this from the class roster from a couple of weeks ago. So can I, and by the way, when you leave, also, once you've given me your name, you can put your calculator on the side. Can I get rows 1 and 2 over on the side to come on up, please? So I can see. Just tell me if your name on there is right and if you go by something else. So first 2 rows, which are the far 2, come on up. Come up to me and tell me what your name is. And that's right?
Yeah.
Okay, thank you.
It's Maddie Alloy.
How do you go? Is it Maddie? Okay, they called down, they need you to step down to your grade level office. Okay?
Courtney.
Courtney what?
Hoffman.
H?
Yeah.
Don't leave until you've seen me. Are you up here?
Yeah.
Courtney, okay, so you're
I
good?
couldn't get on the Excel thing.
can try again tonight.
Okay.
If not, stop and see me, and we'll go try to do it together.
Okay.
Haley? Okay, thank you.
Alyssa down.
Alyssa? Okay. Good?
Joe Smith.
Yeah, you're good, right? Thank you. What's your name, honey? Are you on here?
Yeah, my name's not like all the way on.
E-R? Oh, you know, okay. Thank you. See me next time, by the way. Were you the one that had the issue with the calculator screen? Okay. Emily, okay.
Johannes today.
Okay, with a K?
Yeah.
Okay, and you go by Johannes?
Yeah.
Okay, thank you.
Jason Brown.
So you're good, Jason? You're good? All right, everybody else, come on over, please. Whether it's good or bad, tell me it's good so I can get your name.
Oh, right.
And you're good?
Yeah.
Okay, thank you.
Victoria, sure.
Victoria?
I go by Vicky.
How do you spell it? V-I-C-K-I-E?
U-S-C-K-Y.
Okay, thank you.
Barely.
Where are you on? You're good? Okay. Alexa, and the right, okay, and you're good? Thanks.
Jessica Rain, DC.
And that's good?
I go by Jess.
Jess, J-E-S-S, okay, thank you. And you're good, Tyler? Okay.
I'm a Smith, that's right.
Smith is good, thank you. Jensen? Okay.
Trevor Paschalidis, that's right.
Trevor, you're good? Okay.
Michael, I just go by the first part of my first name.
Michael?
Jacob.
Okay, so this is gone, and you're good? Thank you. Chloe, okay. Do you go by Jonathan or John?
Either one.
Which one do you want? You get to pick. Jonathan, okay.
Allison Los Angeles.
Allison, do you see where you are on here? Oh, this one? And that's good? Okay.
When you said the grade level, just change the...
I think it's the one, downstairs by the cafeteria. Okay? Hang on one second.
I'm a Nat.
Nat, and you're good? Okay, thank you. Yes, but
Just a question, but how come on this last one it was I didn't